Good morning everyone. Today we will see the design of column problem based on axial loading. Myself Dr. J. Sagairuban, Professor and Department of Civil Engineering, Rohini College of Engineering and Technology, Kanyakumari. The problem based on rectangular column design, that size of the column is given by 450 by 450 by 600, subjected to an axial load of 200 kN. The column has an unsupported length of 3 meter. The ends are held in position but not in the direction. M20 concrete and Fe415 seals were used in this column. The effective length is 3000 mm. Then without the member is 450 and overall depth is 600 mm. Then service load is given as 200 kN. That material used in this column is M20 grade and Fe415 steel. In this problem, we have to check whether this column is a short column or long column. For that, we have to find out the slenderness ratio. Here the end are fixed, so Lex, Ley is equal to 3000 mm. Then slenderness ratio L effective length divided by D is equal to, that is 3000 divided by 600 mm. Like you have to find out the value of L effective divided by B, that is less than 12 mm. So that the effective length by least lateral dimension is less than 12. So hence the column is a short column. Next we have to find out the minimum eccentricity in the longer direction as well as the shorter direction. Minimum eccentricity normally we take it from the codal provision. E minimum is equal to effective length divided by 500 plus D divided by 30. First we have to find out in a longer direction the minimum eccentricity. So E minimum is equal to, substitute the value of effective length, that is 3000 divided by 500 plus 600, that is D divided by 30, that is 26 mm. Also we have to find out the E minimum value, that is less than 0.05 D, that is 0.05 into 600, that will be equal to 30 mm. Like in the shorter direction also we have to find out the minimum eccentricity value. Once again substitute the value here and finally we will get a value of 21 mm. Like that E minimum is less than 0.05 into D, so value is 22.5 mm. So the minimum eccentricity are within the codal provisions value. So we have to design, you have to use this section as axially loaded column and design based on the codal provisions guidelines. We have to design the short axially loaded column. Already we find that this is a short axially loaded column. Then we have to design a reinforcement. So here that service load only given. First of all we have to find out the ultimate load. That is we have to multiply by the partial load safety factor. So 2000 into 1.5, that will be equal to 3000 kilonewton. Next we have to design a reinforcement. So design a longitudinal reinforcement. It is given in class 39.3, page number 71 of IS 456 2000. Pu is equal to 0. FCK into AC plus 0.67 Fy into AAC. Or otherwise we have to write the equation like Pu is equal to 0.4 FCK into AC plus 0.67 Fy minus 0.4 FCK into AAC. So we know all the values apart from AAC. Area of steel in compression zone we have to find out. So substitute the ultimate load 3000 into 10 power 3 is equal to 0.4 into FCK is 20, then AC is the area of the concrete. So 450 into 600 plus 0.67 Fy, we know the value of Fy 450 minus 0.4 into FCK is 20 and AAC. So by solving this equation, we finally find out the AAC value. So AAC is equal to 311 mm square. In this problem, the column size is quite high, so we have to provide additional bars. Like already we provided 4 corners bars. Apart from 4 corners bars, we have to provide additional bar. Like provide 4 numbers of 25 mm at the corners. That area of the 25 mm bar is 4 numbers of pi d square by 4. that will be equal to 1964 mm square, and additional we have to provide 4 numbers of 20 mm diameter, that value is equal to 1256. So the total AST, that is area of steel in compression, is equal to 3220 mm square. Already required is 3111 mm square. We provided more than that. Also we check whether we are providing minimum reinforcement. So P is equal to 100 into ASC provided 3220 divided by size of the column, will get 1.192. That value is more than 0.8, that is minimum steel required. Hence it is okay, that reinforcement already we provided is enough to carry that load. Okay, next design of transverse reinforcement or lateral ties. The diameter of the tie normally taken as 1/4 of diameter of main reinforcement. So 1/4 of 25, that will be equal to 6.25 mm, or we have to use a 6 mm diameter lateral ties for the column. Next we have to find out the spacing for lateral ties. First one is, there are three conditions, 300 mm, 16 into pi, least lateral dimension. For that, which one is least, we have to take it as a spacing. So provide 8 mm diameter bar at 300 mm center to center. So this is the design of transverse reinforcement. So this is the reinforcement detail for a given column. So size of the column 450 by 600 mm. The corner we provided 4 numbers of 25 mm diameter bar. At the middle we have to provide 4 numbers of 20 mm diameter bar. So the ties is 8 mm diameter bar at 300 mm center to center. Thank you.